Okay, hello. Hope you can hear me okay. So what are we doing today? Doing this Kaggle competition. Already there would be a link in the description if I don't forget. Let me just, where's my face detector? So this code was generated by ChatGPT and Copilot. If it's still, let's see if it's still working. That's when it's dark, it keeps flicking around. That's not great. It needs more light. I think my other camera for whatever reason is actually working a bit better, but that's being used by another software. This one needs more light and it's adjusting the zoom and everything. Working okay, just check the hands. Yeah, it will sometimes lose them as well. Not sure what's up if that could be improved. Otherwise, generally it's working great. You can see the mouth moving. It is actually moving. Just leave it there for a sec. We were actually looking at the. So there is a data being generated with someone. Oh, it's actually changed to a color, meaning it's detecting the other hand. Yeah, like this. It's detecting both as left or something. But yeah, so it got a few hiccups and things, but generally working okay. And right, so we were looking at somebody else's code, pre-processing the data. So we have this dictionary there. It doesn't look like dictionary, but we have this different speakers spelling, sign spelling these phrases. So we should have the ground truth for it and all, but I couldn't actually find it. Right, we have this phrase character length. For some reason, there's a lot with 12 characters. Don't know why. It's okay. Just suspecting are they spelling the same thing? Are there multiple videos of someone spelling the same phrase? I don't know. So yes, there's 59 unique characters, just some sort of sanity check. And this is the actual data. This 1000. It's like 10,000. So each parquet file contains 1000 recordings, and just I guess printing some of it. You need to know what all these data points, what the different data channels actually mean. So we have generally we have, is there only X? Meant to be X, Y, Z. Yeah, Z supposedly not reliable, so it should not be used. So I think at the bottom of the code actually clearing nans, but I think it can be discarded outright because there's no depth to the thing. I think it's only the, essentially my understanding is that it's X, Y coordinates of each finger. For some reason, so there's a frame number, sequence ID is all the same. Okay. I guess you will have or we can check data, unique identifier, phrase, character prediction. So then you have those landmark data. So this will be the coordinates of the hands. So they extracted using this MediaPipe Holistic model. It's the same one that I'm using on my camera, as you can see in the video. So that's what it looks like. You can extract the different features. So I'm extracting both the face and the hand.
The landmark files contain the same data as in the ASL Science competition, minus the row ID column, but reshaped into a wide format. This allows you to take advantage of the parquet format to entirely skip loading landmarks that you aren't using.
The white needs to be reshaped into wide format. This allows you to take advantage of the parquet format to entirely skip loading landmarks that you aren't using. Okay, don't really get it, but take the word for it. So we have sequence ID.
A unique identifier for the landmark sequence. Landmark files contain approximately 1,000 sequences. The sequence ID is used as the data frame index.
So I'm having trouble with my headphones.
The unique identifier for the landmark sequence. Landmark files contain approximately 1,000 sequences. The sequence ID is used as the data frame index.
We of course want Australian English. Oop, just happened. What? It's to download something for it. Interestingly, the voices in Edge browser are much better.
A unique identifier for the landmark sequence. Landmark files contain approximately 1,000 sequences. The sequence ID is used as the data frame index.
It's pretty bad.
A unique identifier for the landmark sequence. Landmark files contain approximately 1,000 sequences. The sequence ID is used as the data frame index.
Just quickly pop it into what's the browser called, Edge.
Sequence_ID, a unique identifier for the landmark sequence. Landmark files contain approximately 1,000 sequences. The sequence ID is used as the data frame index. X/Y/Z type landmark index. There are now 1,629 spatial coordinate columns for the X, Y, and Z coordinates for each of the 543 landmarks. The type of landmark is one of face, left hand, pose, right hand. Details of the hand landmark locations can be found here. The spatial coordinates have already been normalized by MediaPipe. Note that the MediaPipe model is not fully trained to predict depth, so you may wish to ignore the Z values. The landmarks have been converted to float 32. Landmark data should not be used to identify or re-identify an individual. Landmark data is not intended to enable any form of identity recognition or store any unique biometric identification. Expand_less view less. Files. 124 files. Size. 189.09
So
gigabytes.
I think it's actually
Type.
not the voice, it's the problem with
CSV,
my
JSON. Character_to_prediction_index.json, 405b.
It's probably not the problem with the generated noise. My headphones. Just try this again quickly.
Phrase, the labels for the landmark sequence. The train and test datasets contain randomly generated addresses, phone numbers, and URLs derived from components of real addresses /phone numbers /URLs. Character_to_prediction_index.json. Train/supplemental _landmark /the landmark data. The landmarks were extracted from raw videos with the MediaPipe Holistic model. Not all of the frames necessarily had visible hands or hands that could be detected by the model. The landmark files contain the same data as in the ASL signs competition, minus the row ID column, but reshaped into a wide format. This allows you to take advantage of the parquet format to entirely skip loading landmarks that you aren't using. Sequence_ID, a unique identifier for the landmark sequence. Landmark files contain approximately 1,000 sequences. The sequence ID is used as the data frame index. Frame, the frame number within a landmark sequence. X/Y/Z type landmark index. There are now 1,629 spatial coordinate columns for the X, Y, and Z coordinates for each of the 543 landmarks. The type of landmark is one of face, left hand, pose, right hand. Details of the hand landmark locations can be found here. The spatial coordinates have already been normalized by MediaPipe. Note that the MediaPipe model is not fully trained to predict depth, so you may wish to ignore the Z values. The landmarks have been converted to float 32. The MediaPipe hand landmarker task lets you detect the landmarks of the hands in an image. You can use this task to localize key points of the hands and render visual effects over the hands. This task operates on image data with a machine learning (ML) model as static data or a continuous stream and outputs hand landmarks in image coordinates, hand landmarks in world coordinates, and handedness (left/right hand) of multiple detected hands. Start using this task by following one of these implementation guides for your target platform. These platform-specific guides walk you through a basic implementation of this task, including a recommended model and code example with recommended configuration options. This section describes the capabilities, inputs, outputs, and configuration options of this task. Features. Input image processing. Processing includes image rotation, resizing, normalization, and color space conversion. Score threshold. Filter results based on prediction scores. Task inputs. Task outputs. The hand landmarker accepts an input of one of the following data types. Still images. Decoded video frames. Live video feed. The hand landmarker outputs the following results. Handedness of detected hands. Landmarks of detected hands in image coordinates. Landmarks of detected hands in world coordinates. Configurations options. This task has the following configuration options. Option name. Description. Value range. Default value. Running_mode. Sets the running mode for the hand landmarker task. Default is image mode. Hand landmarker has 3 modes. Image, the mode for detecting hand landmarks on single image inputs. Video, the mode for detecting hand landmarks on the decoded frames of a video. Live_stream, the mode for detecting hand landmarks on a live stream of input data, such as from camera. In this mode, result_callback must be called to set up a listener to receive the recognition results asynchronously. Image, video, live_stream. Image. Number_hands. The maximum number of hands detected by the hand landmark detector. Any integer 0. 1. Min_hand_detection_confidence. The minimum confidence score for the hand detection to be considered successful in palm detection model. 0.0 to 1.0. 0.5. Min_hand_presence_confidence. The minimum confidence score for the hand presence score in the hand landmark detection model. In video mode and live stream mode, if the hand presence confidence score from the hand landmark model is below this threshold, hand landmarker triggers the palm detection model. Otherwise, a lightweight hand tracking algorithm determines the location of the hands for subsequent landmark detections. 0.0 to 1.0. 0.5. Min_tracking_confidence. The minimum confidence score for the hand tracking to be considered successful. This is the bounding box IOU threshold between hands in the current frame and the last frame. In video mode and stream mode of hand landmarker, if the tracking fails, hand landmarker triggers hand detection. Otherwise, it skips the hand detection. 0.0 to 1.0. 0.5. Result_callback. Sets the result listener to receive the detection results asynchronously when the hand landmarker is in live stream mode. Only applicable when running mode is set to live_stream. Not applicable. Not applicable. Models. The hand landmarker uses a model bundle with two packaged models, a palm detection model and a hand landmarks detection model. You need a model bundle that contains both these models to run this task. The hand landmark model bundle detects the key point localization of 21 hand knuckle coordinates within the detected hand regions. The model was trained on approximately 30K real-world images, as well as several rendered synthetic hand models imposed over various backgrounds. The hand landmarker model bundle contains a palm detection model and a hand landmarks detection model. The palm detection model locates hands within the input image, and the hand landmarks detection model identifies specific hand landmarks on the cropped hand image defined by the palm detection model. Since running the palm detection model is time-consuming, when in video or live stream running mode, hand landmarker uses the bounding box defined by the hand landmarks model in one frame to localize the region of hands for subsequent frames. Hand landmarker only retriggers the palm detection model if the hand landmarks model no longer identifies the presence of hands or fails to track the hands within the frame. This reduces the number of times hand landmarker triggers the palm detection model. Task benchmarks. Here's the task benchmarks for the whole pipeline based on the above pre-trained models. The latency result is the average latency on Pixel 6 using CPU/GPU. Model name. There are now 1,629 spatial coordinate columns for the X, Y, and Z coordinates for each of the 543 landmarks. The type of landmark is one of face, left_hand, pose, right_hand. Details of the hand landmark locations can be found here. The spatial coordinates have already been normalized by MediaPipe. Note that the MediaPipe model is not fully trained to predict depth, so you may wish to ignore the Z values. The landmarks have been converted to float 32.
Why this? I couldn't see those in the data. Shape. Yeah, we use that code example for running this thing. Section describe. So we have all the data downloaded. I'm sure there's more than 121 parquet files, but okay. I had 68 train landmarks, 53 supplemental landmarks. What else can open? Open a parquet file. Just trying a notepad plus. No, it doesn't work because it must be a binary of some sort. We do have it running in Python. We had a separate code for it. Oops, sorry. I was having trouble first running this code. Yes, so we have this example code, right? Okay, let's just keep reviewing it because it helps us understand what is it we're looking at. Yeah, this thing did not work in Python itself. Number of unique frames. That means 0. What does 0 means on this plot? So it's mostly 150 unique frames. Don't like those annotations, are not very handy. Same number of unique frames to use, 400. Okay. You also had trouble running this TQDM. So it's probably dropping the Z axis. That says the data wasn't trained on it, so you can only get the XY coordinates. Indices and process data by axis with only dominant hand. How do you select the dominant hand? Number array. I didn't know which one is dominant hand. Number of none frames. So I thought the none from just looking at the data quickly appeared only in the Z axis, which could have been removed anyway. So I'm not sure you need to remove nuns. Number of frames in each video with hand coordinates. Right, so it's pretty much just filtering the data, the frames. Yeah, this thing, we might have trouble with this, obviously, because we're trying to run it locally in Python, but this one of the rules of the competition is you have to run it with TensorFlow Lite. So I guess we'll have to be online. Empty hand, frame filtering, pad zeros, downsample. Okay, why do we need to downsample? I don't know. Squeeze batch dimension. Return data. Target arrays processing input videos. So I'm not sure if the actual videos are just the coordinates of the hands, similar to, where was it? Yeah, this bit. So it should have all these 20 coordinates for essentially each frame. Yeah, I'm not convinced that pre-processing is great. All unique parquet files. Process frame, no empty frame indices. That's okay. Right. Is it padding with 59? Why? It's mostly 59. Not sure why the padding is required. You just keep going from scratch. We had it running already. Is it on there? What there? Right. So we had this Jupyter notebook running. Why? Bizarre. Visual Studio Code Insiders. So we had some errors, convert float, none to integer, things like that. Things still running though. Should be the Levenstein distance, which is the scoring for this competition, should be 1 in this case, because it's one character difference. But this code is not running. Restart this thing, sorry. Number frames per phrase character. Keeps doing the same thing. Right, so this is more like it. Just run this code as well. We have it saved as well, I'm not sure. Just run it all. What we get is back to the pre-processing stuff. Right, so that's essentially what we eventually working with. Those error bars, they're always identical, so I know they are. This standard deviation and means. Get dominant hand, mean standard deviation. Get left right hand, mean standard deviation. What? So you have right hand moving, changing position there. Lips. What is the lips bit? It's not lip reading, is it? Pretty sure it's not. It's not in this document. Three subplots. Pa, 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 pa. Lips landmark. Lips landmark face IDs. Still don't know what that is. Face, phrase. Face detection. Running mode, models. Place face.
Running underscore mode. Sets the running mode for the hand landmarker task. Default is image mode. Hand landmarker has three modes: image, the mode for detecting hand landmarks on single image inputs. Video, the mode for detecting hand landmarks on the decoded frames of a video. Live underscore stream, the mode for detecting hand landmarks on a live stream of input data, such as from camera. In this mode, result underscore callback must be called to set up a listener to receive the recognition results asynchronously. Image, video, live underscore stream. Image. Number underscore hands. The maximum number of hands detected by the hand landmark detector. Any integer 0. 1. Min underscore hand underscore detection underscore confidence. The minimum confidence score for the hand detection to be considered successful in palm detection model. 0.0 to 1.0. 0.5. Min underscore hand underscore presence underscore confidence. The minimum confidence score for the hand presence score in the hand landmark detection model. In video mode and live stream mode, if the hand presence confidence score from the hand landmark model is below this threshold, hand landmarker triggers the palm detection model. Otherwise, a lightweight hand tracking algorithm determines the location of the hands for subsequent landmark detections. 0.0 to 1.0. 0.5. Min underscore tracking underscore confidence. The minimum confidence score for the hand tracking to be considered successful. This is the bounding box IOU threshold between hands in the current frame and the last frame. In video mode and stream mode of hand landmarker, if the tracking fails, hand landmarker triggers hand detection. Otherwise, it skips the hand detection. 0.0 to 1.0. 0.5. Result underscore callback. Sets the result listener to receive the detection results asynchronously when the hand landmarker is in live stream mode. Only applicable when running mode is set to live underscore stream. Not applicable. Not applicable. Models. The hand landmarker uses a model bundle with two packaged models, a palm detection model and a hand landmarks detection model. You need a model bundle that contains both these models to run this task. Attention, this MediaPipe Solutions preview is an early release. Learn more. Model name. Input shape. Quantization type. Model card. Versions. Hand landmarker, full. 192 by 192, 224 by 224. Float 16. Info. Latest. The hand landmark model bundle detects the key point localization of 21 hand knuckle coordinates within the detected hand regions. The model was trained on approximately 30K real-world images, as well as several rendered synthetic hand models imposed over various backgrounds. The hand landmarker model bundle contains a palm detection model and a hand landmarks detection model. The palm detection model locates hands within the input image, and the hand landmarks detection model identifies specific hand landmarks on the cropped hand image defined by the palm detection model. Since running the palm detection model is time-consuming, when in video or live stream running mode, hand landmarker uses the bounding box defined by the hand landmarks model in one frame to localize the region of hands for subsequent frames. The hand landmarker model bundle contains a palm detection model and a hand landmarks detection model. The palm detection model locates hands within the input image, and the hand landmarks detection model identifies specific hand landmarks on the cropped hand image defined by the palm detection model. Since running the palm detection model is time-consuming, when in video or live stream running mode, hand landmarker uses the bounding box defined by the hand landmarks model in one frame to localize the region of hands for subsequent frames. Hand landmarker only retriggers the palm detection model if the hand landmarks model no longer identifies the presence of hands or fails to track the hands within the frame. This reduces the number of times hand landmarker triggers the palm detection model. Task benchmarks. Here's the task benchmarks for the whole pipeline based on the above pre-trained.
So I think in the competition, the data is already pre-processed. Can ignore the Z coordinates. It already normalized. We had code for it. Having trouble opening a folder. What? Right. We have this code. This is the code that does what you see. That's the processing for my webcam. Had another code opening the camera in browser. So that could be handy. It could be a later tool for bodychaos.com. Landmarks. Right, so we're importing that here. That's detection. The pre-processing bit. Type spec. What? Tensor spec. Right, so we have it running. We had some error messages, but got the output. This is not time, is it? 84. That's weird. I'm rubbish. Yeah, this code. Touch this. Nothing wrong with this code. Yeah, it does the same. So I thought originally when looking at this, it meant to be simultaneous data. It's actually something else. Trying to understand then what this is. Right, so we had a code somewhere. Opening this stuff. That's actually mostly working. This work as well. Right, so this example is running now. Yes, this will be one. Change this. So we do again. I have a TensorFlow running. Yet we had this error. Before, but it's still an error. Now let's say JSON file. We know where the JSON file is. Copy as path. We need an R before, just so it recognizes it regardless of which way the slashes go. Gaggle kernel runtime. I think we can just set this to false. This is something that is only relevant to Jupyter Notebook Online. What? Let's just get rid of it. The train. train CSV. Pretty sure I already did this before. That's okay, I'll do it quickly. Right, so we have that many samples. Right, so we have these phrases, and we should have the coordinates for spelling it out. No, this will be wrong as well, wouldn't it? So let's default this folder. And programmatically change those, but do it quickly manually because I forget. A train. Right. Now we need those files from pre-processing. Couldn't read the content. What? How come it's giving the output? Yes, these folders are wrong. Let's see, did we get any result? Still running. Is this model? Yeah, that's meant to explain the model, but yeah, good luck. Well, yeah, this one's a bit step learning rate. Only 2 epochs. Wait. DK callback. Evaluating the model baseline. And that's the score. Right. Those numbers. Yeah, we've seen those numbers before. So those are pretty bad. They're meant to be all around 0. So what would be the average? Around 40? Mean 14. So is this before training? Validation, same 14. Yeah. That's that's not great. But that's being zipped for submission. Yeah, I'm pretty sure this is a pretty bad performance. I'm not sure. Let's look at this score for this for a sec. Leaderboard scores 0.7. So this score is from 0 to 1, whereas the Levenstein distance would be, so it's somehow normalized, is it? Valuation.
The evaluation metric for this contest is the normalized total Levenstein distance. Let the total number of characters in all of the labels be n and the total Levenstein distance be d. The metric equals n, d, n.
This text-to-speech is much better.
The evaluation metric for this contest is the normalized total Levenstein distance. Let the total number of characters in all of the labels be n and the total Levenstein distance be d. The metric equals n, d, slash n.
Right, so this will be normalized.
In this competition, you will be submitting a TensorFlow-like model file. The model must take one or more landmark frames as an input and return a float vector, the predicted probabilities of each sign class, as the output. Your model must be packaged into a submission.zip file and compatible with the TensorFlow-like runtime version 2.14.0, which we are running using Python 3.10. You are welcome to train your model using the framework of your choice, as long as you convert the model checkpoint into the flight format prior to submission. Your model must also perform inference in less than 5 hours and use less than 40 megabytes of storage space. Expect to see approximately 35 hours of video in the test set. Each video is loaded with the following function. Def load underscore relevant underscore data underscore subset, pq underscore path return pd read underscore parquet, pq underscore path, columns equals selected underscore columns. If you want to load only a subset of the landmarks, include a file named inference underscore args.json in your submission.zip with the field selected underscore columns containing a list of the landmark columns you want to use. If that is not included, we will load all columns. Inference is performed, roughly, as follows, ignoring details like how we manage multiple videos.
Is it a video though? I wasn't. Just didn't return any video.
Inference is performed, roughly, as follows, ignoring details like how we manage multiple videos. Import flight underscore runtime dot interpreter as flight interpreter equals flight interpreter model underscore path required underscore signature equals serving underscore default required underscore output equals outputs with open slash kaggle slash input slash fingerspelling character map slash character underscore to underscore prediction underscore index dot json or as f character underscore map equals json dot load f rev underscore character underscore map equals j I for I j and character underscore map dot items found underscore signatures equals list interpreter dot get underscore signature underscore list dot keys if required underscore signature not in found underscore signatures raise kernel eval exception required input signature not found. Prediction underscore fn equals interpreter dot get underscore signature underscore runner serving underscore default output equals prediction underscore fn inputs equals frames prediction underscore str equals dot join rev underscore character underscore map dot get s for s in np dot argmax output required underscore output access equals 1. Fingerspelling is more than just letters, numbers, and symbols. Context matters. For example, when a word has double letters, there are multiple ways it might be signed. Coffee is particularly interesting. A signer might form the letter COF and then slide their hand to the outside of the body while holding the F hand, then form the E and slide the hand yet more to outside the body while holding the E hand. This behavior can be spotted pretty easily as signers are taught to try to keep their hand in the same place while fingerspelling to improve understandability. The sliding motion is unusual. An alternative to sliding double letters is to unflex the fingers and reform the letter. Using coffee as the example again, the signer would form the F hand, which looks like the common American gesture for OK, then open the circle made by the thumb and index finger and reform it. The E would be made next, and the fingers would be unflexed and then reformed into the E hand again. A final method that signers sometimes do is bounce the letter to indicate that it is a double letter. Coffee again is an interesting case because signers may use one or more methods within the same word. Hope this information helps. Found an example video on YouTube that shows a couple examples of the reforming, most of them, and the sliding, Jeff, cool, door, zoo. Check out pizza. The word sign is sometimes performed with just the double Z, puzzle, and jazz, which shows how double ZZs can be formed. https:// Pizza. The word sign is sometimes performed with just the double Z, puzzle, and jazz, which shows how double ZZs can be formed. htt. Thanks a lot for the explanations. They will definitely be helpful. I was wondering whether you would happen to know of resources/examples that show how the symbol characters that occur in a dataset are executed in ASL, i.e. exclamation point. Hashtag $% and single quote asterisk plus comma dash / semicolon equal sign question mark. While it is quite easy to find background info about the letters and numbers, I haven't found any documentation about these yet. Aside from the competition, I'm also asking out of... Thanks for the question. I've made it part of pro tip number 4. Fingerspelling can be very fast. Quintoposis observes 5 to 8 characters per second. Longer words are fingerspelled quicker than shorter words. Just like phonemes in speech, some letters may be elided, dropped. When an experienced signer is receiving fingerspelling, they look at the overall shape of the word rather than each individual letter to understand it. Sometimes when a signer is producing a word quickly, like ELEPHNT, they will focus on producing the first few letters and the last letters clearly but may muddle or drop letters in the middle, ELEMUDDLNT. The receiver can disambiguate the sign pretty easily given the context. For fingerspelled words that are new to a conversation, example, a person's name, or require precision, example, phone #S, fingerspelling may be slower. Known words, example, city names, may be faster and have more elision. Comment. Pro tips on fingerspelling number 4, easy letters, hard symbols, and an online dictionary. Only 2 letters in ASL fingerspelling have motion, J and Z. Their characteristic motion makes them easy to spot during fingerspelling, and since they are relatively rare letters, their presence in a word are a major clue as to what the word is. P and Q are distinct in their own way. For both, the hand is tilted down, and that only occurs for these 2 letters. Fingerspelling chart. Unfortunately, these hand shapes are not common in videos used to train hand trackers, which may have difficulty in producing correct landmarks. However, the downward motion made when switching from a preceding letter to A, P, or Q followed by the upward motion for the next letter should be a pretty strong feature. Unfortunately, these hand shapes are not common in videos used to train hand trackers, which may have difficulty in producing correct landmarks. However, the downward motion made when switching from a preceding letter to A, P, or Q followed by the upward motion for the next letter should be a pretty strong feature. Symbols in ASL can vary greatly from signer to signer. However, some, like plus, can be consistent. One way to get a sense of how these symbols are signed is to type the English name of them into the SMRT Sign Dictionary. Try typing plus or quote. Or visit the dictionary on YouTube. HTTPS. The license on most of the dictionary videos is for educational use only, so they cannot be used for the competition.
Right, so this is interesting. Why, if the videos are made for educational use, why can they not be used for the competition? Makes me wonder. Yeah, I haven't actually read all the rules. Interestingly, yeah, data access and use search. Yeah, it's a attribution license and no additional restrictions. So as long as I'm mentioning where I got it from, it would be good to go. Any Yes, this can be used commercially as well. And I don't know what the Apache 2 can be. Interestingly, on the YouTube channel, it looks like there is like a bot signing, like an avatar, which can be handy. And the competition said that some of the phrases are synthetic. Oh, there was obviously previous competition.
Has the most recent sign language recognition version of the pop sign game mentioned at Google I/O. It was the focus of the last competition. My team at Georgia Tech continues to work on integrating the game creation engine Unity with MediaPipe Holistic and TensorFlow-like models. Right now, it is working very well with MediaPipe hands, but we need to do a lot more optimization to get Holistic to perform correctly. However, PopSign AI Preview now has 7 playable levels based on a 2D CNN variant for the recognition. It works pretty well and has been tested to work well on Pixel 7, 7 Pro, and even Pixel 4a. The next challenge is compiling it for iOS. Wish us luck.
So I think that's the app that was used to generate the data.
PopSign AI is in preview mode. The first 7 levels are available. Testing is performed on the Pixel 7 and 7 Pro. Other phones are not officially supported yet. GC teaching an infant sign language accelerates their language skills, whether they are hearing or deaf. See www.popsign.org. PopSign is an educational bubble shooter game developed by Georgia Tech and RIT/NTID Center on Access.
I know it's something else. I didn't quite get how do they get the...
See some public notebooks where preprocessing is applied, where we are identifying dominant hand and after that manipulating the data based on which hand is the dominant hand. Can someone explain what is being done and how it helps? For example, this public notebook by Irohith. My notebook, I am assuming two things. Fingerspelling is done using only one hand and it is done using the dominant hand. After analyzing a few sequences, we can see that the non-dominant hand has more missing frames than the dominant hand. So I am selecting the dominant hand by looking at the no of non-nan frames. Low no of non-nan frames equals dominant hand. Well, it just as you wrote, he did it this way and it worked. If you think that you have a better way to handle the data, just try it, and we will be very happy if you succeed and publish your solution. Understand that, but I want to know the reason behind this and the transformation applied, which I couldn't understand. At Irohith, can you explain this or direct us to some resource where it can be found?
Yeah, it's fine how in I guess in a lot of this competition there will be some somebody's made an assumption or made a mistake, whatever, and then it will be traveling all through other code, other people's code, because they just take the base thing and run with it. So we might finish this here and continue, take it offline, try to make our code do something more useful. Do I need to run it in Python 3.10? So they said to use the TensorFlow Lite. Looking at this quickly, yeah, if we're storing is it A, B, C, D, E, F, G, H, I, J, I guess, dating like this, A, K, L, M, so M and A are the fingers inside. Yeah, it's crazy. N is super hard. Yeah, so I guess A, M, N, you'll get false detections, false calls for it. Oh, then the angle of the hand would matter quite a bit. A P, Q, R, S. So S and M, very similar, just the thumb is outside. T, and looks weird. U, V, W, X, Y, Z. How Z is actually you air, do an air thing. That's very handy. We could have some sort of tool that teaches so we can identify the coordinates from images instead of doing it from video footage. So we could take that. In theory, that should be in the dataset. Yet this dataset is a bit weird. We're having trouble with those parquet files. Quite understand. Right, so that point on right and left hand is quite interesting. Yeah, so someone was saying how when spelling out, you will mainly use, well, obviously one hand. You don't need the other hand for this. That's just the train folder because there's a supplemental, a landmarks folder. Character to prediction index. Character to prediction index, okay. Do I run the next thing? And the pre-processing should have saved a new folders. Yeah, I might just take this offline. See you in a bit.